Hello everyone. So I think you are missing my classes. So here I am with the topic. I think we should go through this class, this video. It's very important because since this lockdown, we don't know when it's going to end, and it should not abruptly uh, affect our studies. So for that reason, here with I am with the fourth module, that is psychrometrics. Fourth module, psychrometrics. I'll be sharing the concepts of psychrometrics in this video. With this, I will be covering the theory as well as the some amount of problems, selected problems I'll be covering over in this video. Okay, please consider this as like seriously sit into the in front of this video, and please try to learn the psychrometrics as much as possible from your side. Okay, and however we'll conduct doubt clearing session for sure. Okay, so let's start with the things then. Yeah. So psychrometrics. So what before starting as my regular habit, we will understand what is psychrometrics here for the basic definition of psychrometrics. So what is psychrometry? It is a study of properties of mixtures of air and water vapor. So looking at this, so I'll just have a look at over here. What is atmospheric air basically? It is a combination of mixture of permanent gases, that is nitrogen, oxygen, some inert gases, all those together, then dust particles, fumes, etc., then water vapor. So this is a total combination. Whenever we talk about the atmospheric air consists of all these things. All these things it will consist of. So now here what is our psychrometric study is all about is we will filter this atmospheric air or that polluted air or whatever it is, that dust, fumes, everything will be there now, that we are going to filter it. So after filtering, what we are getting a combination of mixture of permanent gases and water vapor. So based on the requirement, we leave this to the so called whatever we say it as air conditioning. We leave this to an AC. So after adding some water vapor or removing some water vapor, depending on the situation, we use this water vapor condition here. So the study of this part is called as psychrometrics. The study of mixture of permanent gases and water vapor, that study is the study of psychrometrics. So for that reason, what is a psychrometry? It is a study of properties of mixtures of air and water vapor, a combination of air and water vapor. The properties of those things is called a study as psychrometry. Atmospheric, and that only I just explained here. So it is a combination of all the gases, pollutants, all the things. So removing that air, moist air, the study of, or we can say psychrometry is the study of properties of moist air. Study of properties of moist air. Okay. With that basic definition, let's move on to the psychrometric properties then. What are the psychrometric properties? So since this is, you might have studied the temperature, pressure, volume, all those kinds of things you might have studied. So what is this psychrometric property? So psychrometric property, here we are talking about some 5 to 6 properties where we use these properties for the measurement of the moist air, condition of the moist air, how it is. Okay, so the first one is the dry bulb temperature. What is this dry bulb temperature? The normal temperature, what you take for measuring your body temperature or for measuring your what is the temperature of the atmosphere as of now. For measuring all these things, the normal thermometer which we use and the results which we get from that normal thermometer is the temperature. The temperature which we get from the normal thermometer, that is the dry bulb temperature. Dry bulb temperature is nothing but the temperature found out by using a normal thermometer. That's a standard thermometer. By measuring that, what the temperature we are noting it down, that will be the dry bulb temperature. Now coming to saturated vapor pressure. What is saturated vapor pressure? What do you mean by saturation first? What is the meaning of saturation? Saturation is a situation where the excess amount of anything cannot withstand. For example, to understand what is the saturation, so let us say you are having a food. So since you are having a food here, so I will serve you one chapati, two chapati, three chapati, four chapati. At the level of the chapatis, at the some level you will be completely filled. After that also there is some space, so I'll put one more chapati. That becomes the fact that you are completely filled. Now if I put also, you'll not have it. That becomes the saturation. You are saturated at that point. So same way, what is a saturated vapor pressure is, if there is the air, if there is a molecule of air here, one molecule of air, so it has some contents, some space where it can accommodate for the water vapor. So it can accommodate some amount of water vapor in this. So this is the air molecule and these are the water vapor molecules. So water vapors. So one air molecule, how much amount of water it can withstand or it can take, that becomes the saturation vapor pressure. It is the saturated partial pressure of water vapor at the dry bulb temperature. This is readily available in thermodynamic tables and charts that we use here. So, and one formula which I have noted down here, this formula is commonly used. Please take a note of this formula. PV equal to PVS WB. WB means wet bulb. I will talk about this. What is wet bulb temperature and what is dry bulb temperature. So we have seen the dry bulb temperature definition. Next I will talk about the wet bulb temperature. This PVS is saturated vapor pressure. This is vapor pressure. This is saturated vapor pressure. So P minus PVS. P is the total pressure. Total pressure. So whenever I say total pressure is pressure of vapor plus pressure of air. So what is this total pressure here? If I consider this molecule here, what will be the total pressure acting on this? P will be, that will be the pressure of the air plus pressure of the vapors. That becomes the total vapor pressure. So PV equal to PVS at wet bulb minus P minus PVS wet bulb, TDB minus TWB. TDB means dry bulb, WB means wet bulb. So 1547 minus 1.44 TWB. These things I will explain it in the class. When the class starts, if you ask me these doubts back to the class, that time I will explain these doubts for you. Okay. Next, coming to relative humidity. So the two properties we have covered. One is the dry bulb temperature, saturated vapor pressure. Then the third one is the relative humidity. So what it is relative humidity? It is defined as the ratio of ratio of mole fraction of water vapor in moist air to the mole fraction of water vapor in the saturated air, or we can say it is generally partial pressure of water vapor divided by saturation pressure, PV by P saturation. That gives you the relative humidity. Then coming to humidity ratio, sometimes it will be shown in W or sometimes it will be shown in omega also, omega or W, humidity ratio. What is humidity ratio? It is defined as the mass of water associated with 1 kg of air, assuming both water vapor and dry air to be perfect gases. The humidity ratio is given by kg of water vapor by kg of dry air. So the kg of water vapor is given by what? PV by RVT. What is this PV by how? PV equal to MRT, we know this. Yes. So M equal to what? PV by RT. That formula we are using here. Same way PAV by RAT. So this is vapor, this is air. So PV by RV, this V, TT goes off. So remaining is PV by RV, PT by PT minus PV by RA. What is this PT minus PV? That I just said you the total pressure is partial pressure, air pressure plus vapor pressure. So for that reason, PA by V, PA can be replaced by PT minus PV. So 0.622 PV by, or we can also write this as 0.622 PV by P. This is also one of the formula which we can use here. That is the humidity ratio. Next, coming to dew point temperature. What is dew point temperature? If unsaturated moist air is cooled at constant pressure, then the temperature at which the moisture in the air begins to condense is known as dew point temperature of air. Simple. If I consider a leaf here, you can see this. a leaf drop a dew. What is the dew? During this monsoon season, there will be a dew will be formed on the leaves of your thing. What is that dew here? How we get this dew is if unsaturated moist air is cooled at constant pressure. Remember this, we are cooling the air at constant pressure, then the temperature at which the moisture is the air begins to condense is known as dew point temperature, at which this moisture begins to condense and making the moisture will be in the gaseous form. It condenses and gets into a liquid droplet. That temperature is called as dew point temperature. Next, coming to degree of saturation. The degree of saturation is the ratio of humidity ratio to the humidity ratio of saturated mixture. This WS should be here. Humidity ratio of a saturated mixture at the same temperature and pressure. So mu is the degree of saturation. It is the ratio of humidity ratio divided to the saturated humidity mixture. Humidity mixture to the saturated humidity mixture at temperature and at a given temperature and pressure. So next coming to enthalpy. Enthalpy of moist air is the sum of enthalpy of the dry air and enthalpy of the water vapor. Enthalpy values are always based on some reference value. Moist air, the enthalpy of dry air is given a 0 value at 0 degrees Celsius, and for water vapor the enthalpy of saturated water is taken as 0 at 0 degrees Celsius. The enthalpy of moist air is given by this formula, H equal to enthalpy of dry air plus humidity ratio into enthalpy of gaseous part or the vapor part, equal to CPT plus W HFG plus CPW into T. So now coming to this is the things here, the explanation of all these things is here. So substituting the values, we get H is equals to, this is the important thing, H is equal to 1.005 T plus W 2501 plus 1.88 T. So wherever if there is only T which is written, that will be dBT. It stands for dBT. Otherwise we'll change it. TDB, TDB. Wherever you want, you can change that to TDB just to avoid confusions. Okay, so that is the thing over here, enthalpy thing. Then coming to specific volume. This specific volume part, you already know it in your fluid mechanics. You have studied the specific volume. What is specific volume? Amount of volume per unit mass, or what reverse of density. What is density? Where it is? Density is mass by volume. If I take it as volume by mass, then it becomes the specific volume. That becomes the specific volume. So V is equal to RAT by PA. So RAT by PA. So RAT by PT minus PV. So that is meter cube per kg of dry air. Okay. So now coming to wet bulb. Initially you have studied about dry bulb temperature. Now here you are learning about the wet bulb temperature. What is wet bulb temperature? That is TWB. You have seen this in the formula here. Which formula? Yeah, here WB, here you have seen here. So for that reason, so what is WB here? Wet bulb temperature. So what is this wet bulb temperature? Now see here, this is the normal thermometer which we are using. To this thermometer, I am coating a cotton wick which is wet into the water, and just I am covering that bulb. This is the bulb which measures the temperature. This bulb I am covering it with the cotton wick. I'm just covering, I'm wrapping that bulb with the cotton wick. Why I am doing so? So when the air passes on this, when a dry air or some air passes on this, while doing so, it catches some amount of, if it is unsaturated, it catches some amount of water vapor into the air molecules. Since it is wet, it will catches some amount of water vapor into that air which is passing onto that. So at that time, what we can see that how much dry the air was or how much wet the air was. So if something is passing onto it, if some molecules are going out, that means what? The bulb, it shows the temperature either rise or decrease. So it shows the temperature. That means what? The air is that much dry or that much wet. We can show it over here. Okay. In practice, it is not convenient to measure the wet bulb temperature using an adiabatic saturator. Instead, a thermometer with a wetted wick is used to measure the wet bulb temperature as shown in the figure. It can be observed that since the area of the wet bulb is finite, the state of air at the exit of the wet bulb will not be the saturated. Instead, it will be at point 2. This is the psychrometric chart which I am going to explain you for sure. Wet bulb, instead it will be point 2 on the straight line joining 1. If this is the situation, it will reach it over here. If the air passes, it will reach over here. Okay, 1. And I provided the temperature of water of the wet bulb is I. If this is the temperature, so it will pass through, it will show us the situation of the dry air, how it will be. Okay, so these are some of the properties of the psychrometric properties. I'll just revise it one more time. So what it is, so here the dry bulb temperature, the normal temperature which we measure from the thermometer. Saturated vapor pressure, the pressure of the air molecule which has enough amount of molecules of moist or water vapor, or the moist air, that becomes the saturated vapor pressure. Relative humidity, vapor pressure, the what ratio of vapor pressure to the saturated vapor pressure. Next, coming to humidity ratio, it is defined as the kg of water vapor to the kg of dry air. Means dry air consists of how much of water vapor, that becomes the humidity ratio. Dew point temperature, what is the dew point at which the unsaturated vapor water vapor, if we condense it at the same pressure, then at what point it gets condensed, or the gaseous form water vapor gets converted into water droplet, that particular temperature is the dew point temperature. Degree of saturation is humidity ratio to the saturated humidity ratio. So that gives you the at a given temperature and pressure. Enthalpy, you know what is the enthalpy? It is the sum of enthalpies of the dry air and the enthalpy of water vapor, or the total heat content of the dry air and the water vapor. So that formula is given over here. Please make a note of this formula. Then specific volume, volume by mass, and wet bulb temperature by wrapping a wetted cotton wick. So that is what the wet bulb temperature is. So hope that you have understood the psychrometric properties. Using these psychrometric properties, we are going to solve the problems that I'll show you over here. Okay, before that, I want to just give an introduction to the psychrometric chart. Please go through your data handbook that Niranjan, Hegde Niranjan. In that, I think it is the last but one page, I guess. I don't have a data handbook over here, otherwise I could have shown you. Last but one page, there is something called a psychrometric chart. You just chuck it in the index, you will get the psychrometric chart. By the name of psychrometric chart only, it is there. You please go through that psychrometric chart and please use that psychrometric chart by the side, and then listen what I am saying it to you. What we have to measure, what are the things, what I am saying it to you. You please keep your side with by the side, you keep your psychrometric chart and just see what all the things I am showing over here. Okay, so at this x-axis there will be dry bulb temperature in degrees Celsius, and at this y-axis there will be humidity ratio. At the y-axis there will be humidity ratio, and the x-axis there will be dry bulb temperature. Now where will be the wet bulb temperature? Wet bulb temperature will be here on this curve. Some of the some other R.K. Hegde, I guess, correct. In which this one, in Nijaguna they had not given this wet bulb temperature separately. In R.K. Hegde data handbook there is wet bulb temperature which is given separately. Both are there. If you are using R.K. Hegde data handbook, then there will be the mentioned wet bulb temperature. If you are using this BT Nijaguna data handbook, blue color data handbook, then this thing what I am saying, you should follow that here. So there, here on this curve there will be the wet bulb temperature markings. Okay, so then coming to these thick lines are there here. These are the enthalpy lines. These are enthalpy lines, and these are specific volume lines. These are specific volume lines they have mentioned here. These are specific volume lines. So whenever for example, whenever some condition is given, 20 degrees Celsius dry, 30 degrees Celsius wet bulb, we can plot those conditions on this psychrometric chart and we can get the values. That is what the importance of the psychrometric chart. So as I'm just giving an introduction to, in this video, I'm just giving the introduction to the psychrometric chart. I'm not at all going to use any psychrometric chart for my problems. But in the next video, next class, I will be updating with the psychrometric chart and the problems using the psychrometric chart only you have to do. So as of now, for this video, I'm just posting you the, just giving you the introduction about the psychrometric chart, how it looks like, such that you should not say, no sir, we don't have data handbook. For that reason, from next class, you must be having the data handbook with you, by the side of you, and we can do the problems on the psychrometric chart. Okay. So this is about the psychrometric chart. Hope I have conveyed you the formulas and all. So let's see some problems. Problems. Some selected problems I have uploaded here using a textbook. I think you have the textbook with you. So if you don't have the textbook, please refer the problems which I am explaining over here. Okay. So a sling psychrometry reads 40 degrees Celsius DBT and 28 degrees Celsius WBT. Calculate the following: specific humidity, relative humidity, vapor density in air, dew point temperature, enthalpy of mixture per kg of dry air. Okay, so these are the things over here. So the given things are what? DBT of 40 degrees Celsius and WBT of 28 degrees Celsius. So this formula we know, omega equal to 0.622 PV by PA. Using this formula, we'll calculate the humidity ratio, because PV and PA you don't know what. So for that reason, first we'll go through this. These are the two formulas which we are going to use here. This formula also I have shown you. This formula also I have shown you in my introduction thing. So you need not assume something. This is what the atmosphere, generally we'll take the atmospheric pressure as, excuse me, 101.325 kilopascal and dBT as 40 degrees Celsius. So saturated vapor pressure will be, if you look at, you have to take the steam tables, temperature, look at the temperature, that will be 40 degrees Celsius. So whatever the pressure will get, that will call it as a saturated vapor pressure, that is this much. And for WBT, 28 degrees Celsius WBT they had given, so PVS WB will get it. So they had given both the things. 40 degrees Celsius will get PVS and 28 degrees Celsius will give PVS WB. So that becomes the thing. Substitute in this, you will get PV as 3 kilopascal or 0.03 bar. So that you substitute in this, you will get 0.019189. That will be the specific humidity. Now to find relative humidity, that is PV by PS, both we have selected, value is taken with respect to DBT. So this you have to just substitute it, you will get the answer as 40%. So vapor density, if you want to find vapor density, that is mass by volume. So PV equal to VV equal to MV RV TV. So that I am just applying the ideal gas equation. So the density becomes this much. So 8.314 divided by 18, that is 0.4618 kilojoules per kg Kelvin. So rho V 3 by 0.027. So this is the rho V. Okay, to find DPT, what is the dew point temperature? Corresponding to the vapor pressure, what is the temperature? That becomes the dew point temperature. Always remember, if you want to find the dew point temperature, wait, the dew point temperature was, I think here, yeah. If you want to find the dew point temperature, so dew point temperature will always correspond to the vapor pressure. At what pressure the vapor is, the corresponding to that will be the dew point temperature. Always remember that. Dew point temperature corresponding to vapor pressure. Corresponding to vapor pressure. Okay. Okay, so you just check the vapor pressure. I have found out that corresponding to that becomes you the dew point temperature. Then coming to the substitution of the enthalpy, 1.00 W omega 2500 plus 1.88 TdB. If you just substitute it, you will get the answer. Yeah, so I have considered the next type of problem here. 1 kg, here mixing problem I have considered. 1 kg of air at 35 degrees Celsius dBT and 60% relative humidity is mixed with 2 kg of air at 20 degrees Celsius dBT and 13 degrees Celsius dPT. Calculate the specific humidity of the mixture by the calculation method only. This we can do with psychrometric chart also, but they are directly saying that please consider this with humidity of the mixture by calculation method only. So using that, here 1 kg of air, here 2 kg of air, they are mixed. What is the things of this? What is the things over here? They are asking to find the things over here. Okay, so for that reason, okay, so this is the formula here which you have to understand. So omega 3 will be omega 1 plus, commonly what it is, this is the basic formula. Omega 1 plus m1 omega 1 plus m2 omega 2 equal to m3. This is continuity equation which generally apply. That same continuity equation only we are using here. So omega 3 will be equal to m1 omega 1 plus m2 omega 2 divided by m3. So using this, m1 1 kg, omega 1 60% air, m2 2 kg of air, specific humidity. So m3 will be equal to m1 plus m2 100%. The mass comes in, the mass goes out. So therefore the total mass will be m1 plus m2, that is 3 kg. So substituting that, omega 3 will be equal to omega 1 plus 2 omega 2 divided by 3. That I have substituted over here. Okay, to find specific humidity, omega 1 0.62 PV. So that using that, phi equal to PV by PVS, 0.6 PV by 5.62. So P equal to PA plus PV. Substitute this, you will get the PA as atmosphere pressure is this much, and omega 1 should be equal to 0.62 3.3. Just to substitute that, you will get the answer. Next, to find specific humidity for 2 kg of air at 20 degrees Celsius dBT and 13 degrees Celsius dPT, just again steam tables, dBT 20 degrees Celsius, you will get PVS, dPT you will get PV. As I said, vapor pressure and dPT are related, saturated pressure and dBT are related. So for that reason, you can directly check over here, find omega 2 will get, this is the omega 3. Okay. So that is the third problem, and the that was the second problem. Last problem is 30 meter cube per minute of air at 15 degrees Celsius dBT and 13 degrees Celsius WBT is mixed with 12 meter cube per minute of air at 25 degrees Celsius dBT and how much it is, 18 degrees Celsius WBT. Calculate dBT. This is 18 degree. Okay, and specific humidity of the mixture. Take atmospheric pressure as 760 mm of Hg. Calculate by the calculation method only. Okay, these all the problems it has been asked. So therefore, same way, m1 h1 plus m2 h2 m3 h3 omega 3 m1 omega 1. This I am for taking the formula 1.005 TB TdB. This formula which you know that I am applying here. Omega 1 A minus PV. So PV, what is the PV they are asking? So PV formula also we have. Calculate that PV formula, but we don't know what is PVS. But 13 degrees Celsius, whatever we get, that becomes the PVS. Substitute that, you will get PV, then omega 1 and then H1. So to find mass M1, PV equal to MART, that is ideal gas equation. Substitute V1, T1, substitute the things, you will get the M1. M2 will be step 2, H2 omega 2 M2 for air at 25 degrees Celsius dBT and 18 degrees Celsius WBT. You find the enthalpy formula, you use the enthalpy formula, you will get the answer. W2 omega 2. So PV, PVS, the thing you substitute in this equation, but again you don't know WBT, what is PVS at WBT. So again you will get it from the data handbook. Substitute in this, omega 2 will get, H2 will get, use the ideal gas equation. That comes to the, again same thing for the third one also. M2 to find dBT, omega 3, H3, TdB, dBT of the mixture is this much and specific humidity is this much. So these are the things. 100% we'll discuss this in a meeting which will be scheduled tomorrow. at the mentioned time, which we have the online class mentioned time. So prior to that, I wanted to upload you this video. Please go through this video well, such that we can have a doubt clearing session for tomorrow's Zoom interview. I will fix it and I'll post it you in the group. We will have a demo schedule as per the timetable, and we will discuss the things in the tomorrow's class. Okay, so I think please consider this video to be seriously consider this 100%, because since we have only having less amount of time, I might not repeat all the things whatever I have done here in the class. So for that reason, I'm making this video. Please go through this video very clearly. Psychrometrics and steam nozzles I will be completing in the online classes only. Please go through this video. Let's have a thorough practice of it and let's be perfect in it. Let's not do for the sake of doing it. Are you understanding, guys? So please do it, take it seriously and do the things. Okay. Till then, for tomorrow, I will see you in the class. So online class or virtual class, I will schedule and we'll see you there. Till that, please go through this video. Okay. Keep learning. Happy learning. Stay safe. Bye.